Hey y'all, the purpose of this video is to do a quick tutorial over editing images of M33, the Triangulum Galaxy, from my Seestar S50. I imaged for about 20 minutes last night, and I think a lot of y'all wanted to see a tutorial of how I process those, and I used PixInsight for that. PixInsight's a pretty expensive program, and I have some plugins that are additional cost built in. I will do this again in Cyril, which is a free alternative to PixInsight, but it's been a while since I've used it, so I want to brush up on that before I put something together because there's probably better guides out there. I am in no way an expert on PixInsight, but it is a hobby and I enjoy it. So we'll jump into the data. I have three folders open. The first one is the data from the Seestar, then the subs from the Seestar, and then my data from PixInsight from where I stacked the data. I think using PixInsight to stack the subs does a better job than what the Seestar does natively. That makes sense. There's a lot more computing power than what the Seestar is capable of. But this is where we start. This is the image directly from my phone. This is after the 20 minutes of imaging the other night, and I think it does a really good job. It captures a lot of data. Uh, it is very clean. You don't see any star walking. I mean, 10-second subs. You don't expect to see much walking, but I think it's good. But we can really use that data to get more out of it, and that's what I'm going to show here. Right here, I have the uh, thin versions, the JPEGs, and then the fit files. I have two because I mistakenly clicked the light pollution filter the first time, and you don't want to do that with the Triangulum Galaxy since that's a narrowband filter. You just want to use the IR filter. From there, what I did is I put all of the lights into a file here, and then in PixInsight, I went ahead and did a batch processing, a weighted batch processing to put those together. Um, to do that, you're just going to go to your lights. You'll upload your light files here. Um, I'm not going to do that because I've already done it. It takes about 10 minutes on my computer for it to put everything together, but you won't have bias darks or flats. You're just going to have your lights. And so in your calibration, you may need to select the option to disable bias darks and flats, and then you can run that. And it'll take, depending on how good of a computer you have, anywhere from a few minutes to up to 15 minutes to combine all the files, depending again on how many subs that you're combining. I've already done that. What happens is it spits out a couple different versions, an auto-cropped version and a non-auto-cropped. I also have a dot fit from where I converted the XISF to a dot fit to play in Cyril. But again, as I get a little more practice under my belt, I'll go back to the Cyril file or the dot fit and edit it in Cyril, make a video. But we'll go ahead and we'll open up this, not the auto cropped, but the original file in PixInsight. It's going to give you a couple different layers. You don't need these. You really just want the RBG integration. I'm going to zoom to fit. And just for ease of use, I'm going to rename this master RBG. Okay. At this point, you can upload your or load your process icons if you have those saved in PixInsight. If you don't, you can follow along just by going to processes and then all processes, and right here they're in alphabetical order. I've just saved them, the ones that I use most often right here, because I kind of go down in order, and so it's easier for me than going through this menu, but they're all going to be right here. So what we have is looks like just a black image with a few dots of stars. That's of course that this is in a linear format. and we need to stretch that, but we'll do some things first to prepare the image before we actually stretch that. So we're going to do the screen transfer function, and this doesn't actually stretch the image, it just shows you what it would look like once it's stretched. I'm going to delink the RGB channels and then apply that auto stretch. And there we are. We're all done. No, just starting. The next thing that we'll do is go to auto background, and there's not much of a gradient here. You can see a little bit as you come up, so we don't need to do much work. We're going to just put 1 degree of function on the output, and right here we're going to put subtraction, discard background model, and replace target image. And then I will go ahead and apply that to the image. We just need to apply the auto stretch again, and that's kind of flattened out the image. You don't see as much of a gradient. We could probably do a little more work, but for this quick tutorial, that's good enough. The next thing we'll do is color calibration. Again, I'm not going to worry about doing a photometric color calibration. I'm just going to apply an automatic color calibration to this image. Next is SCNR green removal. This just, again, kind of calibrates the color, gets rid of some of the green that comes through. And we've got our colors ready to start the rest of the process. This next step is a deconvolution, and this is a paid plugin. I'm using a trial version of it right now, but I absolutely love it. You can also use the easy processing suite if that still works on PixInsight. I've seen that some things that with recent updates, I'm not sure if it does or not, but I really love anything that RC Astro has put out. And so we're going to apply this. This will just fix up the stars and in the image. Okay. And then another one from RC Astro, Noise X Terminator. The noise reduction in the easy processing suite is amazing, but I think this does an even better job, and it does it a lot faster. Based on this image, I'm going to set this down to 0.65, and I'm going to apply that, and you're going to see just how amazing of a job this does. Here we go. Really smooths that out without losing too much of the detail of the galaxy. So we can close this out. We're going to go ahead and actually stretch the image now because it's still really a linear file. We just have a preview stretch on it. And so I'm going to drag the settings up from the screen transfer function here, and then just do an auto stretch by dragging this from the histogram transformation tool onto the image. We just need to turn this preview off, and there we go. Our image is now fully stretched. From here, I'm going to use, again, another tool from RC Astro, and that's Star X Terminator, to create a star mask and create a star image and a starless image. You can also use Star Star Net for that. I think this just, again, does a better job. So I'm going to go ahead and start that. There we go. And so we have our star image and our starless image. You can close this. To help with some pixel math later on, I'm going to call this just S for stars. And I'm going to rename my master RBG to SL for starless. Okay, we can set this aside for now and just put it right here. Now we're going to do a method of adding some color to this. Something similar to a process I do when I'm using narrowband filters, but since we use an IR filter, instead of splitting the RGB channels, we're going to split just the luminance channel. We're going to extract that, and we've got this luminance channel. We really don't need to do anything with it. We can just put that right here, but we're going to go to LRGB combination. I'm going to open that up, and we're going to select that luminance channel we just created. And then we're going to deselect the RGB and inherit astrometric solutions. We're going to select chrominance noise reduction. And then we're going to take this saturation slider and we're going to drop that down. The lower the number, the more color this is going to add. Okay, and we're going to drop that onto our starless image. And you can really see that it adds that color in very nicely. From there, though, we can really take it to the next level. We can get rid of this luminance channel. We don't need that anymore. And we can open up our curves transformation tool. Open a live preview so you can see how you're going to change the image. And we'll start with the red channel. And we're going to take the mids up about a quarter of the way. And then we'll take the shadows down right there. And that looks pretty good. We're going to apply that, add some red to that. And we'll reset this, and we'll do the same thing for the blue channel. I'm going to bring the mids up, and we'll bring our shadow. Oh, clear that. Actually, select your blue. There we go. Bring your blue channel up, and then definitely bring down your shadows in the blue. Okay. And now we have this kind of funky magenta color here. And so we're going to go and we're going to use a script. I have it saved over here as an icon, but just since this is not a process, I'll show that. Go to Utilities, and then go to Correct Magenta Stars. We don't have any magenta stars, but this works very well for getting rid of this magenta hue. You don't need to change anything. Just leave the defaults and apply that, or hit execute, excuse me. And that really gets rid of that magenta color there. So I'm going to close that out. From there, we'll do another iteration of SCNR green removal. Okay, didn't do much, but sure it helped a little bit. And then we can go back into our curves transformation, and we can just add a little bit more blue back in, but definitely being a little more sparing this time with that. I think maybe just 1/8 of the way up there. Okay, that looks pretty good. All right, so now we're going to deal with this noise that's in our background, this color noise. And to do that, we're going to create a range mask with the range selection tool. And we'll start a live preview. And I'm going to set the fuzziness to 0.2, which is my default, and smoothness to 20. And then we're going to use this lower limit slider here to look at this live preview and bring that down as much as possible, where we're grabbing the galaxy in white, but as much of the background as possible in black. And somewhere in between 0.19 and 0.2 seems right. So let's split the difference here. That looks pretty good. We're going to create that mask and close the real-time preview. And we're going to apply that mask to the image. We'll go up to mask and we'll invert that. And then we don't need to see that mask anymore. What we'll do now is go back to our curves transformation, open up a live preview, and we're going to select our luminance channel this time. And from there, we can start dropping the shadows, maybe bringing up the highlights a little bit. And we'll do this in iterations. So we can reset. And this time, maybe bring up the mids just a bit, but drop those shadows. give that a second iteration, and maybe even one last. Okay, that's pretty good. I think anything else we can clean up in Lightroom. So I'm going to close out my curves transformation tool and remove my mask. And that actually removes it from the image just by deleting the mask over there. And now we're going to do two things to add a little bit of detail back to the galaxy itself. This works better with nebulas, but we're going to try it anyways here. And that's, again, to go to Script, Utilities, Dark Structure Enhance. And I like to apply this to almost any image I'm working on. And it just adds a little bit, introduced a little noise this time. Let's go back and forth. Oop. I may actually leave it off this time. Another step to add a little bit more back to the detail back to the galaxy. We're going to go back to our range selection tool, and this time do a pretty aggressive mask. So again, setting default back to 0.2 and smoothness to 20. And now this time we're really going to make sure we're not getting any or as little of the background as possible. We'll create that mask. We're going to drop that mask onto our image. This time we do not need to invert it. We want to leave it right where it's at. And we're going to use the local histogram equalization tool. We'll open up the live preview, and this is where we can get pretty dramatic. So right now the 1 being the amount is as much as you can add, or you can add nothing. And what this does is add some structure back in, and usually anywhere from about 0.25 to 3 seems to be the sweet spot when I'm looking at images. Anything more, I think you're getting a little too much, a little too crazy. But we'll go 0.3. That really is up to you on what you want to do. I'll start there, and I think that's just fine. So I'm going to go ahead and get rid of that and remove that mask. Okay. So I think we are good with the starless image. And so we can put that aside, and we're going to look back at our star image. And with this, you can see that when we remove it, we see that we lose a lot of the color of the stars. And so we'll do the same thing. We're going to create a Luminance channel, and we're going to just go to LRGB combination. We're going to select that new star Luminance channel, disable RGB, and inherit astrometric solution. Select chrominance noise reduction, and then again with the saturation we'll take that down, but we'll be pretty aggressive and we'll take that down to about 0.8, and we're going to apply that to our star image, and you can see that you get a lot of color back into these stars. So we can close this out now, and we have our two images, and we'll zoom to fit on that as well. And we're going to go to pixel math, and right here it's just as simple as S plus SL, the names of our two images here. We're going to select our destination. We'll just create a new image, and we're going to call that M33, and we'll run that. And that combines the images back together. And we can, again, zoom to fit. And we have our combined image, which looks a lot better than our raw image that we brought in, or the one that was created on the Seestar S50. From there, if we want to do any last bit of touch up, we can bring that into Lightroom or Photoshop, whatever you prefer. I'm going to go ahead and save as. I'm just going to save that to my desktop. I'm going to save it as a PNG. It's not going to save, it's going to put that to a 32-bit format. It's not going to save all the information that's stored in the .fit files. That's okay, we don't need that anymore. And we can lower PixInsight, lower our files, and then drop our PNG file into Lightroom. I'll add that photo. And let's zoom to fit. There we go. And from there, what we can do is just, let me zoom in a little bit, get somewhere in the middle. There we go. And we can start playing with some of our basic sliders and bring up the exposure a bit, bring up the contrast. Take down the blacks for sure. Maybe bring up the white, add some brilliance back into it. That may have been a little aggressive. And then coming down here, we've already done most of the work with the noise and sharpening. We'll add a little bit of sharpening, but mask that pretty aggressively using on my Mac, which it's Alt. Moving the slider, you can kind of see where you're impacting sharpening, and then just add some slight noise reduction. Lightroom does a great job of that. So now we move back, and that is our image. You can see that we do have a little bit of gradients issues, but that's something that we could crop out later on. It's not a huge issue, but I think we come up with a pretty good product for 20 minutes on such a compact system like the Seestar S50. So we'll go ahead and export that JPEG. Have it already saved from the last time I made this, and we're going to export this photo to desktop, export, and let's take a look at that. So when we look at this, when we look at what we had originally, there are your two versions. And I think you can see that while the Seestar does a great job for the product that it is, I think its value is in the data that you really have inside the subs, and being able to put it into processing software to pull that out. It does a great job of imaging. There's just some additional steps to really get it to its full potential, and I love the Seestar. So this was just a quick tutorial, but you know, I'm going to keep working on these, keep refining how I use the data from the Seestar, and then, like I said, as I get, you know, a little brush off some of the cobwebs, some of the dust, I'll get another tutorial up for Cyril, which is the free version of PixInsight, and we'll do this same process again, maybe with a different image, or maybe going back to this one so we can see the compare and contrast the results, and try that out in Cyril. I hope this was helpful, and certainly, you know, let me know if you want to see something different, or have any suggestions. Like I said, I am not a pro by any means or stretch of the imagination. This is just a hobby, and I enjoy it. So thank you all for watching, and clear skies.